Hello everyone, welcome to my YouTube channel. Today we are going to discuss 0620 paper 42 October-November 2023. Let's start from question number 1. This question is regarding electronic configuration of some atoms and ions. So there are some atoms and ions from A to G. So student will have to answer in the terms of A to G, the atom or the ion that can be used once, more than once, or not at all. So this part state which of the atoms, the ions A to G could be a noble gas atom. Noble gas atom is a group 8 element, and all group 8 elements except helium, they have 8 electrons in their outermost shell. So we can identify the elements by having 8 electrons in its outermost shell. Helium has 2 electrons. Rest of the noble gases, they have 8 electrons in their outermost shell. So B is the answer, which has 8 electrons in its outermost shell. So B. An atom of an element in group 6. The group number of an element is linked with the number of electrons in the outermost shell, or valence electrons. So if you look at the valence electron, group number is equal to number of valence electron. Group 6 means the element must have 6 electrons in its outermost shell. As you can see in the F, there are 6 electrons. So F is the answer. An atom with an atomic number 14. Atomic number 14 means atomic number is the number of protons which are present in the nucleus of an atom, and number of protons and electrons, they are equal in an atom. So just add the electrons of D. So if you add the electrons 2 plus 8 plus 4, you will get 14. So D is the element which has atomic number 14. Atoms from the same group. Same group mean they must have identical or same number of electrons in their outermost shell. So if they have same number of electrons in their outermost shell, they must be present within the same group. If we look at the two elements, let me check. A has 5 electrons in its outermost shell. E also has 5 electrons in its outermost shell. So A and E, they are present within the same group of the periodic table. A halogen atom. Halogen atoms are group 7 elements, and all group 7 elements, they have 7 electrons in their outermost shell. So just check that the element or the atom of an element having 7 electrons in its outermost shell. G is the atom of the element of noble gas having 7 electrons in its outermost shell. So G is the answer. An atom of an element which is a good conductor of electricity. This is the property of metal. And normally the transition metals, or the metals of the group 1, 2, 3, they are good conductor of electricity. So just check either the transition element or the element from group 1, 2, and 3. So they must have 1, 2, or 3 electron in their outermost shell. As you can see that C is the element which has 2 electron in its outermost shell. So this is good conductor of electricity. A stable ion of group 5 element. The group 5 elements, they have 5 electrons in the outermost shell. And if they gain electrons, definitely they can form the stable ion. For example, if we take the example of nitrogen and phosphorus from group 3, sorry, 5. So nitrogen can form 3 negative having 7 proton number. Phosphorus can also form 3 negative having 15 proton number. So N3 negative must have 10 electrons and P3 negative 18 electrons. So these are the stable ions of group 5 elements within the first 20 elements. So if we have 10 electrons, 2, 8 will be the electronic configuration, and for 18, 2, 8, 8. Just look at our list that either the element must have the 2, 8 or the 2, 8, 8 electronic configurations. So we can see that B has 2, 8 electronic configurations. So B is a stable ion of group 5 element. An atom that forms an ion with the 2 negative charge. 2 negative charge mean the element must be in group 6 of the periodic table, because group 6 elements, they have 6 electron in their outermost shells, so they have the ability to gain 2 electron to get the noble gas electronic configuration. So 6 electron is in F. So F is the answer. Let's move to the second question. Cobalt and copper are the transition elements. Copper has 2 naturally occurring isotopes, copper 63 and copper 65. Cobalt has only 1 naturally occurring isotope, copper 59. Complete the table 2.1 showing the number of protons, neutrons, and electrons in cobalt and copper. So this is the atom. As we can see that there is no charge, but Cu2 positive is the ion. So we'll have to keep in our mind that the ions, they have the different number of electrons as compared to the protons. So CO59, just look at the periodic table. Cobalt has 27 proton number or the atomic number. So it must have 27 protons. So let's say 27 protons in cobalt. Copper, 29 proton number, so must have 29. Then to get the neutrons, 59 minus 27, you will get 32. So 32 in cobalt, and 65 minus 29, you will get 36. So 36 neutrons in copper. Now, because cobalt is the atom, so the number of protons and electron must be same. It must be 27 electrons. But Cu2 positive is the copper 2 ion. 2 positive mean loss of 2 electrons. 29 is the proton number. So if copper, let's say that if copper is the atom, 29 protons and 29 electrons must be there. But if it loses 2 electron, you will get 2 less electrons as compared to the protons. Or every proton is positively charged. So if we say that plus 29 and every electron is negatively charged, minus 27. So plus 29 minus 27, you will get plus 2 answer. So that's why the charge on copper is 2 positive. Then this is the question regarding relative atomic mass. Copper has 2 isotopes and their relative abundance and the mass numbers are there. So if we want to calculate the relative atomic mass, the formula I use is mass time abundance or mass time abundance over total abundance, or you can say that the sum of the mass time abundance of the isotopes over total abundance. So the first isotope has the mass 63 times abundance is 70, plus then the next isotope having 65 times 30 is the mass abundance, and the total abundance is 70 plus 30, 100. So 63 times 70, then 65 times 30 over 100. So you will get 6360 divided by 100, and the answer is 63.6. So the next part, one physical property of the transition elements such as copper and cobalt is that they are hard. Other metals such as lithium is soft, so transition elements are generally hard and the group 1 elements are generally soft. So state two other physical properties of the copper and cobalt which are significantly different from the lithium. So uh, actually in this question, he's talking about the physical properties of transition elements, and the students, they must have the idea about their syllabus, that in the syllabus there are some physical properties of the transition elements, that they have the high melting and boiling points, then they have the high density, and they are hard and they are heavy, they are good conductor of electricity. So if we check the physical properties of transition elements. So they have their high melting and boiling points, high melting and boiling points. Or you can also say that they have the high melting points as compared to group 1, and they have their high densities as well. And the third property is there, that was about the conductivity. You can also say that both the elements are conductor, okay, but this property, the hard transition metals are hard and group 1 metals are soft. So this is the difference between the physical properties of transition metals and group 1 elements. Both copper and cobalt can form colored compounds. This is another property. Some of these compounds contain water of crystallization. Define the term water of crystallization. Generally in your syllabus, that if we write hydrated compounds like copper sulfate dot 5H2O, and this compound is hydrated compound, and these water molecules are water of crystallization. So the water of crystallization molecules mean the water molecules present in hydrated compound. The water molecules present in hydrated compounds. Then the next part is state the color and the formula of hydrated cobalt 2 chloride crystals. The cobalt 2 chloride and the copper 2 sulfate, these are the two crystals. They are used to test water molecules. So if I say that, let me write the equations. By writing these equations, you can easily understand the concept. Copper sulfate plus water, you will get copper sulfate hydrated, or copper sulfate pentahydrate, and this is hydrated cobalt 2 chloride. So if you balance these equations, so these are the balanced equation. Now the copper sulfate, which is anhydrous, that is white in color, cobalt 2 chloride, which is anhydrous, that is blue in color, hydrated copper 2 sulfate is blue, and hydrated cobalt 2 chloride is pink. So a student should remember the colors of hydrated and anhydrous copper 2 sulfate and cobalt 2 chloride. So state the color and the formula of hydrated cobalt 2 chloride crystals. As you can see that this is the hydrated cobalt 2 chloride crystal. So the color is pink and the formula is COCl2.6H2O. So this is cobalt. Be careful. Don't write the formula like this. Because this oxygen, if we show the oxygen as a capital, so this shows the carbon, mean oxygen means the carbon monoxide. So that's why the oxygen must be in the small alphabet. Then state the color change seen when a few drops of water are added to anhydrous copper 2 sulfate. As I have already mentioned that anhydrous copper 2 sulfate is white in color, anhydrated copper 2 sulfate is blue. Anhydrous copper 2 sulfate is used to test the presence of water, so it will change from white to blue. State how this color change can be reversed. As you can see that how we can reverse the color. This is the equation. So if anhydrous copper 2 sulfate, if it is converted into hydrated, we can add water, and hydrated copper 2 sulfate can be converted into anhydrous by heating, because by heating we can separate the water of crystallization or the forces of attraction which are present between copper sulfate and water molecules, or water of crystallization, they can be overcome. So if we heat the hydrated copper 2 sulfate, we can get the anhydrous copper 2 sulfate. Copper 2 sulfate. Okay, the next question. Iron is manufactured in a blast furnace. Three of the starting materials added to the blast furnace are coke, and then iron ore. Generally, hematite is the iron ore is used. Then a limestone. Limestone is calcium carbonate. And name the other starting material. So carbon plus iron trioxide or hematite plus calcium carbonate and the hot air. So these are the four raw materials. So the fourth raw material is hot air. The source of iron in the blast furnace is Fe2O3. Fe2O3 is found in the iron ore. So the main ore of the iron is hematite. The iron ore hematite, okay, the iron is Fe2O3 reduced by the carbon monoxide. So let's balance this equation. There are two irons, so if we put 2 here, now we can balance the oxygen. So there are 3 oxygen, and then there's 3 plus 1, 4 oxygen, and there are 2 oxygens. So, but we have to balance the carbon as well. So if 3 oxygen, if we put 3 here, it becomes 6, and by balancing carbon, there are 3 carbon atoms, we can put 3 here. So 3 carbon, 3 carbon, 3 plus 3, 6 oxygen, 3 times 2, 6 oxygen, 2 iron. State the change in oxidation number of the iron in the reaction in 2. So this iron 3 oxide is, we know that the sum of oxidation states in a compound is 0. So the oxygen is -2. So if we take the sum of 3 times -2, it is -6. And 2 should be multiplied with 3 to get +6. So +3 is the oxidation state of iron on the left-hand side. And on the right-hand side, iron is uncombined. So uncombined elements, they have their 0 oxidation state. So the change in oxidation state is from +3 to 0. Explain how the change in oxidation number shows that iron has been reduced. Decrease in oxidation state is the reduction, as we can see that the oxidation state decreases. So decrease in oxidation state is reduction, and increase in oxidation state is oxidation. So if decrease in oxidation state or decrease in oxidation number, we can see that that substance is reduced. The major impurity in iron ore is silicon fluoroxide. Limestone is added to the blast furnace to remove this impurity. Write 2 symbol equations to show that silicon fluoroxide is removed, and then type of the chemical reaction. So chemical equation 1. So limestone is added in the blast furnace to remove the impurities of silicon fluoroxide. So the impurities of silicon fluoroxide, they are acidic, and silicon dioxide or silicon fluoroxide is SiO2, and limestone is calcium carbonate. So it decomposes to give calcium oxide and carbon dioxide. Generally 950 to 1000 degrees Celsius temperature is required. So when one reactant or one compound is broken down to form different substances that upon heating, that is the thermal decomposition. So this is the thermal decomposition of calcium carbonate. Then equine 2. So this calcium oxide is basic, that is used to remove the impurities of silicon 4 oxide, and silicon 4 oxide is acidic. So we will get a single product as one calcium, one silicon, 2 plus 1, 3 oxygen. So we can write CaSiO3, calcium silicate, which is called slag. Now the type of reaction, this is basic, this is acidic. So we can say this is acid-base reaction or neutralization reaction. Then iron is converted to the steel by making it with carbon and other elements. State the term given to the substance, which is a mixture of a metal and a other element. A mixture of metal and other element is alloy. Name one element other than carbon mixed with iron in the making of stainless steel. Stainless steel is generally made up of iron, carbon, and manganese. So the element which is responsible for this, it may be the chromium, manganese, or nickel. So this may be the nickel or the chromium. Preventing the rusting of a steel is important, and state the chemical name of rust. The rust is hydrated iron 3 oxide. Hydrated iron 3 oxide, like this is the iron 3 oxide, and hydrated is H2O. It may be XH2O, like 2H2O or 3H2O. Steel can be coated with the zinc to prevent rusting. People have already studied about some method of preventing rusting. Sometimes sacrificial protection, sometimes cathodic protection, sometimes coating with the paint or grease, oiling, coating with the plastic. So let's see that F1 state the term used to coating steel with zinc. If zinc is coating, then that is the galvanized iron. So this term is galvanizing. Describe another barrier method for preventing rusting. So we can either paint, or we can coat with the plastic, or we can grease. By greasing, by painting, we can prevent rusting. Then explain how zinc provides sacrificial protection. If we have a iron piece, and if it is coated by the zinc, if this is iron, and if it is coated by the zinc, so zinc provides sacrificial protection to the iron, because zinc is more reactive than iron, so it reacts with the moist air in preference to iron. So number one, zinc is more reactive than iron. So it reacts with moist air, moisture and water in preference to iron. Because zinc is above iron in the reactivity series, so zinc is more reactive. This question is regarding salts. Lead 2 chloride. A student prepares a sample of insoluble lead 2 chloride, PbCl2, by mixing aqueous solutions of 2 salts in a beaker. Identify 2 soluble salts suitable for making lead 2 chloride. If you are making the lead 2 chloride, you have to remember the solubility of salt. So all nitrates are soluble. First of all, pick the nitrate of the first metal. This is soluble. Then all group 1 salts are soluble. So pick the group 1 salt of chloride. So you can say sodium chloride. So to get the insoluble lead to chloride, we must have the two soluble salts. So the soluble salts are lead to nitrate, and sodium chloride. So if we have to prepare, let's say if we are going to prepare the lead to sulfate, which is insoluble salt, so we can identify in a same way that the two soluble salts of which are used to get lead to sulfate, number one, take the nitrate of lead to nitrate, and take the group 1 salt of sulfate, sodium sulfate. So insoluble salts can be prepared by mixing the soluble salts. Write the ionic equation for the formation of lead to chloride. Now, lead to chloride is PbCl2. So by skipping the spectator ions, we can get the ionic equation. Lead is 2 positive, so just write 2 positive. Chloride is 1 negative, and both these ions are present in the aqueous form. So aqueous solid, and then balance this equation. List the steps the student should take in preparing a pure sample of lead to chloride from the mixture in the beaker. So if we have prepared the lead to chloride, how can we get the pure sample of lead to chloride? Lead to chloride is the insoluble salt. So the first point should be that filter the mixture. If we filter it, then we will get the lead to chloride. First of all, filter. Then, if we filter here, we can get the lead to. Here's the filter paper. Here we can get the PbCl2. Then we'll get the filtrate in the lower beaker. Now, the PbCl2 is here in the form of a residue. So to remove the traces of soluble salt, we should wash with the distilled water. Then wash the precipitate or wash the residue with distilled water. And the third point should be that dry the salt, and we can dry the salt between the folds of filter paper, and the salt is PbCl2. So dry the PbCl2 in folds of filter paper. So filter, wash, and dry. So these are the three keywords a student must have in his mind. Okay, next question. This is regarding the electrolysis of molten lead to chloride. Molten lead to chloride. So the formula, the same formula is used. This is lead to chloride. Molten lead to chloride. Now, explain why lead to chloride needs to be molten before it will conduct electricity. Because in solid state, the ions are at a fixed position, cannot move, but the molten lead to chloride, it has mobile ions. So mobile ions are responsible for the conductivity. So in solid, ions are at their fixed position, cannot move, but in liquid, movable ions conduct electricity. For the conductivity, either the free or the delocalized electrons or free ions are responsible. For the metals, delocalized electrons are responsible for the conductivity. For ionic compound, movable ions are responsible. So write the ionic half equation for the reaction occurring at cathode. Cathode is a positive electrode, generally negatively charged ion, Cl negative. They will move towards the anode, and Cl negative, they're converted into chlorine gas because anode is a positive electrode. Negative ions, when moved towards the anode, the oxidation will take place. Oxidation means loss of electron. So if you want to get Cl2, we can get from 2Cl negative, and 2 electrons must be given out. So at anode, there is an oxidation, loss of electron. So chloride ion lose electron to get chlorine gas. Test for the chlorine gas. Chlorine gas is it has a bleaching nature. So if we put damp litmus paper, and that is bleached. So chlorine has a bleaching nature. Chlorine bleaches moist or damp litmus paper. Describe what is observed at the cathode. So at the cathode, we will get lead, and at anode, we will get chlorine. Generally, chlorine is a green gas. So at anode, we can get the green vapors or smell of bleach. Then lead is the metal which is obtained at cathode, and this is shiny gray or shiny solid. So shiny gray solid is obtained at cathode. Then chemical reactions can involve transfer of thermal energy. State the term we use for the transfer of thermal energy during the reaction. So this is enthalpy change. So enthalpy change of the reaction. Enthalpy change of reaction, delta H. This question is tetrachloromethane gas reacts with the steam to form the products, and the reaction is reversible. The forward reaction is exothermic. So this is exothermic. So the reverse reaction must be endothermic, and the overall enthalpy change must be negative. Exo means the overall enthalpy change must be negative, and the reverse reaction or the backward reaction is endothermic. State what happens, if anything, to the rate, only rate of the forward reaction if the concentration of CCl4 is increased. Explain your answer in the terms of Coulombian theory. If we increase the concentration, definitely the rate of the reaction increases. So the first point is that rate of reaction increases. If we have more amount of CCl2 particles per unit volume, because the concentration increase, so we have more CCl4 particles in a unit volume. Particles in a unit volume. If we have more particles in a unit volume, there must be more collisions per second. We can say that the collisions per second's frequency, so frequency of collisions between our reactants, between CCl4 and water particles, that increases. So rate of reaction increases because we have increased the concentration, and concentration means the number of particles in a unit volume. If we increase the concentration of CCl4, more particles there in the unit volume. And if there are more particles, more collisions per second. More collisions per second is frequency. So frequency of collision will increase. So that's why we'll get the rate higher than the previous one. State what happens to the position of equilibrium. Now this is the regarding the position of equilibrium. If anything, when the pressure is increased, pressure is concerned with the number of moles of the reactants and the products of gases. So all the reagents are gases. So there are 3 moles of gases on the left hand side and 5 moles of gases on the right hand side. So if we increase the pressure, the reactant, the position of equilibrium shifts from more moles to less moles. As we can see that the more moles on the right hand side and less moles on the left hand side. So when the pressure is increased, the position of equilibrium shifts to left. as more gaseous moles are on the right side. On right side of equation. Or we can say that more moles of products. Then this is the energy pathway diagram of this particular reaction. So we have to show the formula of the reactants in the product, then enthalpy change and activation energy. So here we can show the reactants. This is the place for products. Then the energy which is required to start the chemical reaction, that starts from reactants. So this is the activation energy. Then the difference of energies of reactants and the product. This is enthalpy change. So this arrow shows the enthalpy change. As we can see that the reactants have more energy than the product. So the reaction is exothermic. So you can show the negative sign with the enthalpy change. Define the term activation energy. So activation energy is the minimum amount of energy that the colliding particles must have to react. So the minimum amount of energy, the colliding particles must have to react. Because this much energy is required for the reaction, and the reactants, they have this much energy. So if reactants wants to convert into the product, definitely we can increase the energy. So this much energy will be provided by these reactants, and then bonds are being broken, and we will get the new combination to get the products. State one way in which the activation energy of a reaction has been changed. There is no effect of temperature, concentration, or pressure on the activation energy. The activation energy can be decreased by the catalyst. So only the catalyst can decrease the activation energy. So catalyst decreases activation energy. Now, the next part is regarding enthalpy change calculation by using average bond energies. This is all the displayed formulas of the reactants in the product. As we can see that there are 4 CCl bond on the left hand side, 4 OH bonds are there, then 2 C double bond O bonds are there, 4 HCl bonds are there, and enthalpy change is given. Let's start from the first part. Calculate the energy needed to break all the bonds of the reactants. So there are 2 reactants, CCl4 and then water. There are 4 bonds of CCl and 4 bonds of OH. CCl energy is 340. So 4 times 340 plus 4 times OH is 460. So this is 460. If you multiply this and add, you will get 3200. Energy, calculate the energy released when the bonds in carbon dioxide form. So carbon dioxide, this is the situation. 2 C double bond O bonds are there. So 1 C double bond O is 805. So it will become 1610. Now, calculate the HCl bond energy. So delta H is sum of bond broken minus sum of bond formed. Negative 130 is enthalpy change, which is given in the question. Bond broken for all bonds of the reactants, 3200, minus bond formed, the carbon dioxide, 1610 plus 4 HCl bonds are there. So if we add these numbers, like minus 130 minus 3220, because we have shifted 3200 and 1610 on the left hand side. So we will get 1720 and the 4HCl. Here we have the negative sign with this and negative sign with this, so we can cancel this negative sign. So the bond energy for HCl is 1720 divided by 430. So 430 is the energy which is released when the bonds of HCl will be formed. Then this question is regarding the organic chemistry. Give two characteristics that are the same for all members of the homologous series. Homologous series, they have the same general formula, then the same functional group, same method of preparations. Then we can say the two consecutive members differ by CH2 group and 14 digits in their relative molecular mass. So you can copy the different characteristics of the homologous series, whose members have similar chemical properties. So this property is already given, so don't repeat this property. So the members of the homologous series, they have the same general formula. Like alkanes, they have the general formula CnH2n plus 2. Alkenes, they have CnH2n. Then they contain the same functional group as well. All alcohols, they contain OH as a functional group. All carboxylic acid, they contain COOH as a functional group. In the terms of structure, state how one member of the homologous series differs from the next member of the homologous series. So that differs by CH2 group. For example, if methane is the first member of the homologous series of alkane, ethane is the second member, C2H6, propane is the third member, C3H8. We apply the general formula CnH2n plus 2. Here we can put the 1, 2, 3 instead of n, so we will get these molecular formulas. So CH4 and C2H6, they differ by CH2 group. C2H6 and C3H8, they also differ by CH2 group. So the two consecutive members of the series, they differ by CH2 group and 14 digits in their relative molecular mass. Now, these are some organic compounds, A, B, C. A has the molecular formula C12H22. If we look at the general formula, then we can apply the general formula CnH2n, because the number of hydrogen and carbon atom, they are present in the 1:2. So this is the general formula of alkene. B has the name tetradecane, as the ending code is N. So this is alkane. 3 carbon atom homologous series. This is the general formula of carboxylic acid. So name the homologous series. A is alkene. B is alkane. And C is carboxylic acids. Okay, so these are the series of alkane, alkenes, and carboxylic acids. Name C and draw the displayed formula. So C has 3 carbon atom, including this carbon atom. So if we add this carbon atom, it means there are 2 more carbon atom. So the name must be propanoic acid. So COOH group, that can be shown. There are 3 carbon atoms, so you can fix the 3 carbon atom. Then there is a carboxylic group that can be shown like this, and rest of the carbon, they must be tetravalent. So you can show the displayed formula of propanoic acid. Mostly, generally the student they can do some mistake, like this carbon must be counted in the carbon. So if you add 3 carbon here and 1 carbon here, that will be the butanoic acid instead of propanoic acid. So count the carbon atom of the functional group. The next part is amino acid or homologous series, where each member has the general structure shown as this figure. R is the side chain. So this is the side chain, and the rest of the structure is fixed for amino acid. An amino acid has the relative molecular mass of 103. and deduce the formula of the R side chain in the amino acid. So if we count all the carbon, hydrogen, and oxygen, so how many carbons are there? There are 2 carbon, and then there's 1 nitrogen, 2 oxygen, and 1, 2, 3, 4, 4 hydrogen, and then 1 R is equal to 103. Okay, so this is 24, this is 14, this is 32, this is 4, plus R is equal to 103. So if we subtract the values, like okay, 24 plus 14 plus 32 plus 4, 36, 14, 74. So R is equal to 103 minus 74. So it will be 80, then 28, 31. It is 31. Okay, now 31, you have to predict the formula of the R group. Generally, the R, it may be the first R alkyl group is CH3, which is methyl. The second is C2H5, which is ethyl. The third one is C3H7, which is propyl. The difference between alkane and alkyl is that this is alkane, CnH2n plus 2. And if alkyl, then it has 1 less hydrogen as compared to the alkane. So CnH2n plus 1 is the alkyl. This is methyl, and if you add the relative atomic masses or the mass numbers, 12 plus 3, 15, and C2H4, 24 plus 5, 29. So if you have a 29, this is 29. So if you have 29, yeah, that was not 31. This is 29. So 29 means you have C2H5 ethyl group. So ethyl group is there. State the name given to the natural polyamide formed from the amino acid monomer. Amino acids monomer linked together to form a protein. So protein has the amide linkage. This is the amide linkage, C double bond O, NH. So amide linkage is there. Amide link is in the protein. So when thousands of amino acids they join together, we will get the protein. This was the last part. Thank you.